Have you ever bought eggs from store, Walmart, or any grocery store? In a box, how many eggs? 12, a dozen, right? But, always my wife suggests me, open, check one by one. Do not buy any box, any eggs broken, always. But why not? Sometimes, it is a delivery from somewhere to the store. So, let me see. 78%. It's most of them. It's clean. No broken eggs. 19%. One egg is broken. 19%. 2%, two brokes. 1%, 3 eggs are broken. That's it. It's no more 3. Okay? Yeah. So we assumed it's up to 3, the broken eggs. What is the experiment? We are going to select one box randomly. Then what? The question is, when we chose a box randomly, what is the chance there is only one broken egg? Can you understand what is the problem? Okay, let me translate into the statistics. Let me make the Venn diagram, because always we have to make the Venn diagram for the base rule. Yeah, in this example, we should apply the base rule. So let me make the Venn diagram here. Sample space. How many A's? How many partitions do you expect? How do you think? I told you before, we need many A's and one B. How many A's? 4? Why?
Because you have 78 that are not broken, 19, 2, and 1 that are.
That is a good one. Let me say A1, no broken egg. A2, 1. A3, 2. And A4 up to 3. 4 A's. No broken. 1, 2, and 3. It's nothing here. 1, 2, 3. And now we have to define what is the B, the event of B. B is we found the broken eggs. That is the event. We found, when we chose one box randomly, the event of B is to find one broken egg. Okay? So let me see. Let me make the B here. What is a B? Just a second. Let me make the B here. Not there, but here. Find a broken egg. That is the event of B. Okay, let me do more. What happens here then? What is this one then? There is based on A4. What was A4? It's actually in the box. There were 3 broken eggs. But randomly, we choose 1. Randomly, we chose a box. And randomly, we choose an egg from the box out of 12. So it is, we found a broken egg from the box. But actually, the box had 3 broken eggs. It's possible, isn't it? right? And how about this one then? When we chose A3, who was A3? It's actually they were 2 broken eggs and 10 clean ones. Unfortunately, I chose the broken egg from the box. How about this one? You know, actually in the box, there is a 1 broken egg, 11 clean one, but I just choose the broken eggs. It's good, right? How about this one? There is no broken eggs, and I chose the broken, just a second. In A1, did we have the broken eggs in the box? Is every egg is clean. It's no broken, right? Can I find impossible? Impossible. You know? It is impossible, right? So I have to make the Venn diagram. It's not like this, but like this one. How do you think? Does that make sense, right? As from here, we couldn't find. We can't find any broken eggs. So the correct Venn diagram looks like this. It's good? Okay, so now we need the probability. So let me set up who are A's and who is the B. So we have to state what is this. That means we need the probability. We found a broken egg. So B should be given. And we need a chance, we need a probability. It is the only one. So from where? If it must be the only one, then it must be from A1, A2, A3, A4. Which one? Where?
A2.
A2. Because the A2, we defined it was the boxes which has only 1 broken egg. Why do we need this one? My wife said, open, check each one, but I didn't. But I paid, parking lot, oh, my wife said, let's check all of them, and open it. Oh my God, one of them is broken, right? What do I need? Oh God, please, this one is the only one, right? I need a probability. When I found it is a broken, I want it is the only one. No more. More? What? No dinner. Okay? So now I need the probability. A2 given B. I need it is the only one when I found 1 broken egg. Can you understand? Okay, now I can apply the base rule. What was that? A2 times probability of B given A2. In the denominator, we take the multiplication all and summation, right? So it is a long summation, but I will expand the summations one by one. So let me take the probability of A1 times the probability of B given A1, probability of A2 times, just a second, I need more space. Probability of B given A2. And actually we had 4 A's, so we are going to take the sum of 4 multiplications one by one. So next one, 3 times probability of B given A3, and the last one will be A4 times probability of B given A4. Yeah, even though it is a small font, but yeah, you could understand. Yeah, what do we need? Did you copy the percentages? Right, we need the percentages. 78%. What is a 0.78? It is the probability of A1, no broken egg. That it is the chance I chose the clean box. As every egg is not broken. And 19%, it is the probability of A2. 2%, the probability of A3. And 1%, it was the probability of A4. They are the marginal probabilities for each A. Right? So let me go back here. How much was that? A2, please?
0.19.
0.19. Just a second. It was not given. B given A2 was not given. But what did I say? I gave you the tip. It is given. You can find. You knew how much is that. What was that? B given A2. Just a second. B given A2. What does that mean? From A2. Where? A2 was, there is 1 broken egg. And the conditional probability B given A2 means from there, we knew there is a 1 broken egg. What is the chance I chose the broken eggs? What is the probability? 1/12, yes. Because we need, a box has 12 eggs, and we knew one of them was broken. So the chance I chose the broken egg is 1/12, yes. It's good? Now, how much was the probability of A1? I remember 0.78. Am I correct? 0.78. Then what is the chance I can choose a broken eggs from there? Impossible. Because we knew in the box, every 12 eggs are clean. I can't take broken eggs. 0. The second one, we took them before in the numerator. So 0.19 times 1/12. And how about the A3? Probability of A3? How much was that? 1%, 2%? Was 2%? 0.02? And now, B given A3. What does that mean? A3. There were 2 broken eggs. 10 clean one. What is the chance I choose either one, the either broken one? 2/12. Good? 2/12. And the very last one, 3 broken eggs, just 1%. And what is the chance I will choose a broken eggs from there? There were 3/12, right? So the chance to choose the broken eggs is a 3/12. Don't stop, do it. Please do the multiplication. And it will be same as this one. How much will be 0.19? Oh, 1 over 12, yes, please. Please.
1 over 12 is 0.083.
0.083, and the second one will be, it's a 0.038 again. And how about, oh, it's nothing, okay. Then can you do this one for me?
On the top, are you multiplying 0.19 times?
Yeah, that 0.083 is just the 1 divided by 12.
And both.
Oh, I'm sorry. Okay, then I need another one. Yeah, I need the multiplication.
It's 0.016.
0.016, and the second one will be 0.016 in the denominator. And can you give me the third one? 0.02 times 2 over 12.
0.003.
0.003, and the last one, please.
0.0025.
0.0025. Okay, keep going. The top one is 0.016, and please take the summation. It is the the probability of B by the rule of the total probability. Whatever, give me the summation. 0.174.
Just 74. Oh, the bottom.
The bottom. Anybody?
0.022.
0.022. And finally, the finally is a 1.17 something.
0.74.
0.74. You know, the base rule, I told you it is the most the hardest one, right? The most difficult one, but it means the longest one, the long calculations, right? Yeah, be careful. Take your time. Step by step, you can take the final answer. That is a 74%. What is a 74%? Which will be C, A2 given B. What? When I selected a box randomly, and then I select an egg randomly, when it is broken, 74%, it is the only one. What does it mean? 26%. What does it mean, 26%? What is the 26%? The other one. That is a probability. I do not have any dinner tonight. That means 26%, they might, another broken eggs. Oh my God.
So 74% is what?
That is the chance it is the only broken eggs.
Okay, so there's only one broken.
Just one, yes. Yeah, see, look at this one. It's trying to understand what is the meaning of this one. A2 given B.
Okay.
B was given. What was a B? I chose a broken eggs from the box.
And
And
then A2 is one.
it was one.
No, there is one.
Means this one is the only one.
Okay.
Yes, what?
Do we have to include, in problems like this, do we have to include the A1, like, at all, or?
Yes. You know, where can I do is mess up. Yeah, please look at this one. You know, we just put here, it's a 0.016. It was from A2 because we needed the probability A2 given B. But in the denominator, we need all. A1, A2, A3, A4.
So even if it's 0, we still include it?
Yes, yes. By the rule. The base rule, there is the conditional probability B given A1. But now, in this example, it was 0. It's nothing. But we need it. See, here was the probability 0.016, and there was the 0.016 again. Always, by the base rule, the denominator is bigger than the numerator. What was the rule number 1? Can you remember that? The rule number 1 in chapter 4 for the probability? Any probability must be less than 1. Now, even long calculations, denominator, the bottom one, that is a summation by the rule of the total probability. Always the denominator is bigger than the numerator. The numerator, it is one of the terms in the summation. So, any kind of conditional probability by the base rule must be less than 1, bigger than 0. Good, right?